All right, you guys, this is 7.3 notes, day 2. So we did day 1 yesterday, and we talked about tangent. And today we're going to talk about the other two trig functions that we use, which are sine and cosine. So here, sine and cosine, they are the other two trig functions. So remember, tangent was opposite over adjacent. That is, the tangent of an angle is equal to the opposite side over the adjacent side. Sine and cosine have their own ratios. Sine here, you can see, is the length of the leg opposite over the length of the hypotenuse. So tangent was opposite over adjacent. Sine is opposite over hypotenuse. So for angle A here, if we wanted to do the length, the opposite over hypotenuse, then the opposite of angle A would be side BC, and the hypotenuse would be BA. So we would put BC over BA, and that would give us the sine of A. Okay, even though it's written sin, you guys, it's pronounced sine. Sine and cosine. Okay, cosine, which got cut off here, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So under this adjacent, we write length of hypotenuse. So if we were going to do the cosine of A, that would be side AC over side AB, the adjacent over the hypotenuse. Okay, so we've just got some different ratios that we're looking at, but still using those sides that we're using for tangent. Okay, so example 1, we're going to find the sine of S and the sine of R. Write each answer as a fraction and as a decimal, round it to 4 places. So we're going to do sine of R first, or sine of S first. So sine of S, if we're looking at angle S, sine, as we look back up above, is opposite over hypotenuse. So we're going to take the opposite side to angle S, which is side RT there, and we're going to put that over the hypotenuse of this triangle, which is side RS. This is the hypotenuse over here. Okay, so this hypotenuse is RS. Then we plug in the numbers that we know they are. So RT is 63, and RS is 65. We can't reduce that fraction at all, so there's our answer as a fraction. And then as a decimal, 63 divided by 65 is equal to 0.96923, etc. So we're going to round that to 4 decimal places. Our answer is going to be 0.9692. So there's our answer for sine S, written as a fraction and as a decimal. Then for sine R, we do the same thing. Set up our fraction and plug in what we know. So the sine of R, again, is going to be opposite over hypotenuse, but it's the opposite of angle R, which on this triangle is side ST. So it's going to be ST over RS, opposite over hypotenuse, which would be 16 over 65. And again, those have no shared factors, so that is fully reduced. And then if we do 16 divided by 65, we get a really long decimal. We're going to round it to 4 decimal places. That's going to be 0.2462. So there is our answer for sine of R, written as a fraction and then as a decimal, written to 4, or rounded to 4 decimal places. Okay. All right, example 2. So that was sine, opposite over hypotenuse. Example 2, we're going to find the cosines of these angles. Cosine is adjacent over hypotenuse. So we're going to first find the cosine of X. So we need to look at our triangle and figure out what side is adjacent to angle S here, X. First off, which side is our hypotenuse here? Always opposite the right angle, so side XY is our hypotenuse. So we know that that will be on the bottom of our fraction. We're going to have adjacent over hypotenuse. So we look at the sides here. Adjacent to angle X is side XZ. So we've got XZ over XY, which is 15 over 17. And that's a reduced fraction. And then we're going to change that into a decimal. 15 divided by 17 equals 0.8824. Okay, there's our reduced fraction and our answer written as a decimal. Okay, then we're going to find the cosine of y, which is going to be the adjacent side of angle y, which is zy, over the hypotenuse, which is xy, adjacent over hypotenuse. Zy is 8, xy is 17. 8 over 17 is fully reduced. We're going to do 8 divided by 17, get a really long decimal, round it to 4 decimal places, which would be 0.4706. 8 over 17, approximately equal to 0.4706. So there's a cosine of x and cosine of y written in two forms. Okay, so again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so example 3 here is to find the sine of x, sine of y, cosine of x, and cosine of y. Write each answer as a fraction and as a decimal rounded to 4 places. Okay, I'm going to go ahead and cross this part off. We're just going to write the answer as a fraction, okay, because I want us to notice something here. So we're going to first do sine of x. Okay, sine is opposite over hypotenuse. So we're going to take the opposite side of x, which is side yz, over the hypotenuse, which on this triangle is this xy. Okay, so we've got xy here. And yz over xy is 15 over 25, which I can reduce to 3 over 5. So sine of x is 3 over 5. Then I'm going to do the cosine of, or the sine of y. Okay, sine of y is the opposite of angle y, which is side xz over the hypotenuse, side xy. Xz is 20 over xy is 25, and we can reduce that to 4 over 5. Okay, then again we're going to come back and I'm going to do the cosine of y, or cosine of x. Okay, so cosine of x is going to be, cosine is adjacent over hypotenuse, so it's the side adjacent to angle x, which is xz there, over the hypotenuse, which is xy. Xz is 20, xy is 25, so we reduce that, we get 4 over 5. And then we're going to go ahead and do the cosine of y. Okay, what do you notice about the cosine of x and the sine of y? They are the same. So we can predict here, and you'll be right, cosine of y is probably going to be 3/5. Okay, cosine adjacent over hypotenuse. The adjacent side to angle y is yz over xy. Yz is 15 over 25. Reduce that, we get 3/5. So, big thing to notice here. Hopefully you guys can all see it, that the sine of x is the same as the cosine of y, and the cosine of x is the same as sine of y. So they are inverse ratios of each other. Okay? Questions on that? Make sure you write them down. You can ask tomorrow. All right, so here's a little story for you guys to give you some background knowledge on these trig functions we're working with. In 1803, the United States purchased over 800,000 square miles of land from the French, which was called the, anyone know what it was called? The Louisiana, let's see if I can spell this right, Louisiana Purchase. The U.S. would then go on to send Lewis and Clark to explore the vast unknown land that they had purchased. On that trip, Lewis and Clark had an Indian guide named SOHCAHTOA, which is very hard to spell, so I'm going to double check my spelling here. SOHCAHTOA is SACAGAWEA. So I've mentioned a couple of times in class recently that SOHCAHTOA had a cousin. So Sacagawea guided Lewis and Clark through this Louisiana Purchase. Well, our guide through trigonometry is going to be SOHCAHTOA. Okay, here's how she spells her name. SOHCAHTOA. And if you were in class on Friday, you were already introduced to SOHCAHTOA. SOHCAHTOA, you guys, isn't a real person. Isn't actually Sacagawea's cousin. It's an acronym that helps us remember what our trig ratios are. So SOHCAHTOA stands for sine, which is opposite over hypotenuse. See where this is going? C stands for cosine, which is adjacent over hypotenuse. And then the third one is tangent, which is opposite over adjacent. So, SOHCAHTOA, which we can remember pretty easily because of the fun little name that it is. SOHCAHTOA, Sacagawea's cousin, is our guide through trigonometry. It's a way to help us remember how to set up the ratios. SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Okay, so remember SOHCAHTOA. It'll help you out a lot as you try to remember these ratios. All right, so we're going to look at this example. So these ones, they're each different type of problem. We don't know for sure which one we're going to use. We got to figure out which ratio to use based on which side lengths we have. So on the first one, we have angle A is given to us. Okay, and for angle A, we have this side length, x, and this side length, 10. Okay, the side length that we don't have on this triangle is we don't have the hypotenuse. So we're not going to be able to use sine or cosine because they both involve hypotenuse. Okay, so we're going to use tangent here. So we're going to go tangent of A, which is opposite over adjacent. So the opposite side of angle A is side BC, and the adjacent side to angle A is side AC. Okay, then we're going to plug in what we know. We know that A is 32 degrees. So we're going to go tangent of 32 degrees equals x over 10. And then to solve this, we're going to multiply by 10 on both sides to get rid of the 10 that's with our x right now. We're going to get x equals 10 times tangent of 32. And then again, if we want to do this without rounding until the end, we're going to take our calculators and listen carefully to our input here. We're going to put in, if you're using an iPhone calculator or a similarly working one, you're going to put in 32, press tangent. That should give you a big old long decimal. Make sure you're in degrees and not radians. And then, so your decimal should be 0.6248693. If it's not that, you're probably in radians. So figure out where that radians degrees button is and switch it. So you should get, after you put in 32 tangent, you should get 0.624869, etc. And then you're going to take that big old long decimal, don't round it, take that big old long decimal and right from there, press times 10 equals. And that will give you another big old long decimal, and that's what you're going to want to round here. So my approximate for x is 6 points. I'm going to go ahead and stick with 4 decimal places here. 2, 4, 8, 7. And that's what you should get for x. What will happen is if you take this tan 32 and round it, you're not going to get the same answer for x because it will not be as accurate because you will have rounded earlier. So don't round early. Alright, again, we'll go over inputting in class to help you with the calculator function. You can also just Google, you guys, how do I put tangent on my scientific calculator? I know you guys know how to use the internet. Okay? I know how to use the internet, and I'm older than you guys. Alright, all that aside. 2 more examples here. Solve for x, example 5. So we got to look at what side lengths are given to us. So across from our right angle, this x length is our hypotenuse. So we know we're going to need to use either sine or cosine. And as we look at the angle that they gave us, this angle 51, that the side that they gave us is adjacent, not opposite. So we have the adjacent side and we have the hypotenuse. So which trig function are we going to use? Cosine is correct. So SOHCAHTOA. Cosine is adjacent over hypotenuse. So the cosine of 51 degrees is equal to the adjacent 8 over the hypotenuse. Okay, this one's a little tricky because we have x in our denominator there, but here's what you'll need to do. Okay, to get rid of x, you can cross multiply, and maybe we want to just do that. So cosine of 51 is really cosine of 51 over 1, and then we can cross multiply here. We're going to get 8 equals x times cosine of 51 degrees. And then what we'll do from there to get x by itself is divide by cosine of 51 degrees. So you end up getting that x is equal to 8 divided by cosine of 51 degrees. And then it gets a little trickier to input this in our function, so we're going to go ahead and change that 51 to a decimal, or round it early. So put in 51, press cosine, and we get a decimal that is about 0.6293, and then we're going to take that and do 8 divided by that. So we have 8 divided by cosine of 51 equals 12.7121. Now that's what I got when I input into my calculator 8. So here, I got this by inputting. So I'm going to put in a different color here. Input. And here's what you press. You put 8 divided by 51 cosine equals. So if you input each of those numbers into your iPhone calculator, you'll get this. And again, that saves the rounding until the very end, which is going to be more accurate. And we'll go over inputting into our calculators when we're in class, okay? And if you have a scientific calculator, make sure you bring it to class. Alright, our last example here, example 6. Gotta get this done in 20 minutes. Okay, so example 6, we've got an angle, we've got the hypotenuse, which is this side AB, and then we've got this side x, which is opposite of this angle. So if we have the opposite and the hypotenuse, SOHCAHTOA, so is we're going to use sine. So we're going to go sine of that 37 degrees equals the opposite over the hypotenuse. And then from here, if we want to get x all by itself, we're going to multiply both sides by 20. It's going to cancel out these 20s, and we're going to have x equals 20 sine 37. And then we can input that into our calculator. 20 times 37 sine equals, and we should get 12.0363. Alright, so there's our introduction here to sine and cosine, and SOHCAHTOA, which is our acronym to help us remember how to set up our ratios for sine, cosine, and tangent. And make sure you guys write down any questions you have. You can also shoot me a remind if you have questions during the video. You can shoot me an email, and then definitely ask the next day in class when I come around to check notes. Alright, see you guys. See you soon.